Okay, Assalamualaikum and good morning to all. Okay, so for today's lecture, okay, we're going to start on the remaining part of topic number 4, which is on discrete probability distribution. Okay, we're going to cover on the last part, which is on Poisson probability distribution. So let me recap what we did last week on binomial distribution. So it is part of one of the two syllabus under the discrete distribution. So the main components in binomial is that you have two possible outcomes and a fixed number of trials, n is fixed. Okay, and then okay, the number of trials are fixed. Okay, two possible outcomes. Okay, and then the probability of success and failure stay the same. Okay, whether you increase the number of n, okay, but the value of pi will remain the same. Okay, so there are three components that you can apply in the formula NCX and pi. N, X, and pi. Okay, pi means the probability of success, and you also will have the number of trials, which is reflected by the n. Okay, so in comparison with the Poisson, okay, Poisson distribution. Okay, so Poisson is under the family of discrete probability distribution. So it describes the number of times some event occurs during a specified interval. It can be time, distance, area, or volume. So what this means is that under Poisson probability distribution, unlike binomial where you're going to have what is the number of trials, okay, and then if you look at the questions that you did last week, okay, and you're going to also have the value of pi, which is the probability of success. So pi means, I mean, it can be from 0 to 1, okay, 10%, 20%, 30%. But unlike binomial, okay, in Poisson, you will not have the number of trials and you will not have the probability of success. So what you will have is a value, okay, or what I can, the value that refers to a specified time interval. Okay, and this value, this probability is proportional to the length of interval. So this is the important one. So for example, there are two accidents, okay, occurring every 2 hours in Malaysia, for example. Okay, then in 1 hour there is two accidents. So in 2 hours, then there will be 4 accidents. So proportional means the value of the probability, okay, is proportional. So if we refer to the specified time in 1 hour, so that 1 hour is the interval time. In 1 hour, there will be 2 accidents. So the value of 2 is the Poisson value, okay. And then if you want to calculate for 3 hours, what is the probability of, let's say, 5 accidents occurring in 3 hours? So then the value will be so the value of Poisson associated with 3 hours. If 1 hour 2 accidents, then 3 hours will be 6 accidents. Okay, so that will be the what we refer to as the specified time interval. So the examples included in this slide is the number of misspelled words or typos per page. So in one page, how many misspelled words? So let's say in 2 pages, so you just multiply by the number of misspelled words per page. Okay, the number of cost per hour, okay, received by this company, the number of vehicles sold per day. So in 1 day, how many vehicles sold? So let's say in 2 days. So again, it is proportional. So if 1 day 20 cars are sold, then in 2 days it will be 40. Okay, the number of goal scored in a match. So in one game, what is the average value of goal scored? Okay, so the formula to calculate Poisson, of course, will be different than binomial. Okay, so in binomial, okay, you have the number of trials and you have the probability of success pi. So those are the two main ones. Okay, and for Poisson, what you have is the mean value or mu. Okay, so you recall we learned mu before. Okay, in chapter, beginning from chapter number 3, the mean. Okay, so mu or the mean is the number of occurrences, success in a particular interval. So just now we referred, for example, what is the number of misspelled words per page. So in one page, what is the mean value of misspelled word or typos? Let's say in one page, there are 20 misspelled words. So 20 will be the mean. Okay? In 1 hour, let's say there are 10 calls. So 10 calls per hour. So in 1 hour, 10 calls. So 10 will be the mean value. Okay, that is referring to the mu here. So E is just the formula, the exponent value. Okay, and X is the probability that we want to calculate. What is the probability of X equals to 2? Okay, just like when you calculate in binomial. Okay, what is the probability of X equals to 3, X more than 3, X less than 3? So X value will refer to the one that you want to calculate. Okay, factorial is you can, if you use your scientific calculator, you will see the factorial in one of the buttons there. So the formula is mu by the power of x, where x is the value that you want to calculate, e by the power of negative mu. So the main thing is the mu value here. So it can changes according to the interval. So if you are given, if you want to calculate what is the number of misspelled words in 2 pages, so the mu will be referring to 1 page. So in 2 pages, you need to multiply by the proportional value. So let's say in 1 page there are 20 misspelled words. In 2 pages, so 2 times 20 will be 40. So the mu will be 40. So that will be applied to any of the questions that you want to refer to. Okay. So just like binomial, you can also calculate the mean. So in binomial, in Poisson, the mean will be n multiplied by the pi, which is basically this one is taken from the binomial concept, okay, where n is the number of trial, pi is the probability of success, okay. But we're not going to refer to this frequently, because usually you can actually convert binomial into Poisson, where if you have binomial questions, you can also convert into mean and use that as the mean value of the, or the mu for Poisson. Okay, so usually but in your syllabus, we're not going to focus on converting binomial into Poisson distribution. Okay, of course, the mean value mu, okay, refers to n times pi. So it is also the same as the variance. So once you calculate, once you have the mean value, okay, the variance is also equals to the n times pi. So basically the mean and the variance is the same value. So mu is also the mean, mu is also the variance. So for example, just now, okay, in this example, so let's say in one page there are 20 misspelled words. So mean is 20, variance is also 20. Okay, so but how you calculate the variance and mean is one thing, okay, which is you obtain by n times pi. But the main point is that in Poisson distribution, the mean and the variance is the same value. Okay, unlike in binomial, okay, if you recall from the previous topic, so n times pi is the mean, variance is n pi 1 minus pi, so it will be a different value altogether. But for Poisson distribution, the mean and the variance is the same value, which is referring to the mu that we are referring to. So this is the first example from the slide. Okay, so you have the mean to be 0.3. Okay, the mean number of lost bag per flight is 0.3. Okay, suppose that a random of 1,300 bags were lost. So 3 out of 1,000, 0.3. So mu will be 0.3. So find the probability of not losing any bag, which is px equal to 0. Okay, so this is the formula that you just plug in, mu by the power of x e negative mu x factorial. Okay, when you plug in all the relevant value, mu which is 0.3. Okay, usually the question will not be like this, meaning in most of the questions in your textbook, okay, or in your quizzes or tests, okay, the value of mu will be provided directly, not in this way, meaning you need to calculate from this information. Okay, so let's look at another. Okay, before that, okay, just like binomial, also you also can refer to the table in your textbook. Okay, so that one will be in page 518. Okay, if I'm not mistaken. Okay, 518, you're going to have the binomial, the Poisson table. So all of this value will refer to the, so this part here, okay, will refer to the mean value or the mu starting from 0.1 until the highest value will be the mean to be 9.0. So if your mean is anything equal to 0.1, 0.2, okay, or until 9, so you can refer to the px value equal to 0, px equals to 1, okay, and the rest goes lah. Okay, so how you read, which is similar to how you read the table in binomial before. Okay, so just now 0.3 is the mean. So you want to calculate px equal to 0. So basically just refer to this x equal to 0 under 0.3. So you get directly the value of 0.7408. Okay, alternatively, you can also calculate this using Poisson calculator. Okay? I think I have not provided you with the link. So I will upload this link in your OL, okay? Or you can just refer to this address, okay? Okay, I will upload this link in your OL as well. So this Poisson calculator is not available in two of the links that I provided before. Okay, so here you have the lambda, which is the mean value. Okay, x equals the value of x that you want to calculate. So just now, let's say our mu is 0.3, right? And we want to calculate no back is lost, px equal to 0. Okay, so here you can get directly. So this one you can change whether you want x equals to sign, x less or equals to, or x more or equals to, which is the same as the previous binomial calculator. So you have three options: equals to, less or equals to, or more than, more and equals to. So if you are given the sign, if you want to calculate more than, for example, okay, or less than, so you need to work your way based on this x value equals to what. Okay, so for example, if you want to calculate x greater or more than 3, for example, okay, then you can get directly from the table here. I mean, because the equation gives you x, because the table only provide these two signs, more or equals to, or less and equals to. Okay, but let's say if I want to calculate x more than 3, okay, so x more than 3 means 4 and above, meaning 3 is not included, right? So 4 and above means x more than 3 is also equals to x greater or more than 4. Okay, correct? So then you can use this one. So meaning here you need to put 4, not 3. Okay. So if you want to calculate x greater than 3, okay, then here you need to put 4. Because when you put 4, you can refer to this one. Okay. So this is referring to x at least or greater than 4. Okay. So we convert x more than 3. More than 3 means 4 and above. So 4 and above means you need to put 4 here. So either way, you need to know how to modify based on the questions given, because the equation similar to binomial. So once you learn the trick, okay, basically just convert more than, okay, to the more or equal to sign. Okay, so that is the Poisson calculator. Okay, so from the table, as long as the value of the mean is the same, then you can refer to the formula there. Okay, or the table there. Okay, and one last part is similar to the binomial discussion. Okay, as when you increase the number of mean or the mu value, your distribution of binomial will be somewhat normal distribution or zero skewness. Okay, you can see that when mu is small compared to when mu is big, okay, 6.0 versus 0.7, okay, it becomes more symmetrical or zero skewness, or what we call normal distribution. Okay, so you can see that the slides for the Poisson distribution is very short. Okay, that's why you can, I think the main thing is practice or exercise. Okay, you cannot just learn just by one example alone. So let's see, maybe we can discuss one questions with the answers provided first. Okay, and then let's see how we then I will give you the questions to do. Okay, so basically, either you can use the table. Okay, you can use the table given, Okay, or you can also use the calculator provided in the, okay, so here you can see that this question, question 25, okay, I take question 26, questions number 50, question number 50 and 52. So there are 3 questions that I require you to do. Okay, so you can see that all of these are even number questions. Okay, so let's see question number 52 first. I'm just giving you the keyword what to do. Okay, per hour is the interval time. You can see here, employees receive an average of 2. So mu, the mean is equal to 2. Okay, mean is equal to 2 for every 1 hour. Okay, so what is the probability that Linda Leahy, okay, this person receive exactly 1 email between 4 to 5. So 4 to 5 is of course 1 hour. So which is the same here. So Px, so you want to calculate exactly 1 means Px equals to 1. So you want to calculate Px equals to 1 provided that the mu is equals to 2. Okay, so this is okay, and the rest is the same. A, B, and C is referring mu is equal to 2 because the time does not change, okay, between 4 to 5. Okay, this is Px 5 or more, mean x greater or equals to 5. So you can use the calculator to obtain this thing directly. Okay, and then this one did not receive any, meaning Px is equal to 0. So you can learn to use the calculator or you can calculate manually. Okay, but for Poisson, unlike binomial, okay, because binomial you have the n value, okay, the number of trials. But for Poisson, there is no number of trials. So let's say when mean is equal to 2, okay, you want to get 5 or more, meaning more 5 and above. So it can be 5, 6, 7, 8, but when do you stop? So actually it can go to infinity. So that's why in Poisson, whenever you want to calculate anything more than, okay, more or equals to or more than, okay, actually you need to use the inverse procedure. Inverse means if you want to calculate greater or more than 5, you need to take the inverse of that, which is 1 minus something. So in okay, so let me show you this. So meaning that you can still use the table or you can calculate manually. Okay, so if you want Px more or equals to 5, okay, just like in the question, okay, Px at least greater than 5, meaning that 5 and above, you can go to 5, 6, 7, 8, but you can go to infinity because in Poisson, there is no number of trials. In binomial, let's say if n is equals to 10, if n is equal to 10, then if you want more than 5 or more or equals to 5, then it will be 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, if you recall from the exercise that we do from last week, okay, this particular example here, okay, yeah, this one, okay, n is equals to 12, okay, and if you want to calculate at least greater than 7, then it will be 7 until 12 because your n is equal to 12. So it cannot go more than 12 because n is fixed in number. Okay, so you can calculate this manually. But in Poisson, there is no n. There is no number of trials. So if you want to calculate more or equal to 7, it can go 7, 8, 9, 10 until infinity. Okay, so how you do it? How do you solve for Poisson? So let's say if you look at this example here, okay, greater or more than 7. Okay, or we go back to this one just now. Okay, you want to calculate at least bigger than 5, meaning 5 and above. So what you do not want is 4 and below. Okay, you want 5 and above. So what you do not want is less than 5. Okay, this is just simple mathematics using the more or less than sign. You want 5 and above. So what you do not want is less than 5, means 4, 3, 2, 1, and 0. Okay, always start with 0 lah, because discrete distribution, it can start from 0. So what you want is 5 and above. What you do not want is 4 and below. 0, 1, 2, 3, and 4. So when I say use the complement rule, so if you want this value, so you need to calculate what you do not want and minus that with 1, because the total probability will always be equals to 1. So you need to calculate Px equal to 0 plus Px equals to 1 plus Px equals to 2 plus Px equals to 3 plus Px equals to 4. You sum all of these 5 events, x equals to 1 until x equals to 4, and the total of this value, 1 minus with the sum of these events, then you will get Px greater than at least bigger than 5. Okay, so you can do this manually using the formula of Poisson, meaning you calculate Px equal to 0, you get the value, okay, and then you calculate Px equals to 1 until you get Px. So you sum each of these value, okay, and 1 minus that should be equal to this one, okay, because total probability will always be equals to 1. So what you do not want plus with what you want will always be equals to 1. Okay, so that is how you solve problems for questions like this if you were to do it using table or manual approach. Okay, but your life using WebEx learning method, okay, is made much simpler because you can just use this calculator directly. Okay, because the calculator already provided you with the greater or more than sign. So if you want to calculate Px, for example, in this question here, 5 or more, then just simply put 5 here, right? Okay, 5 here, and then the lambda just now, the mean is equals to 2, right? There are two emails per hour. Okay, so the main thing is the mu equals to 2. 1 per hour is just the interval time. Okay, so for example, let's say if I add one more question or if I change this one, what is the probability that she did not receive any or Px equal to 0 during 2 hours? Okay, so 2 hours means, let's say during the period means is 1 hour. But let's say if I change this last word, few words here, during 4 to 6 p.m., meaning in 2 hours. So 2 hours, your mu cannot be 2 anymore. It must be 4 because 1 hour, 2 emails. So 2 hours, it should be 4. So then mu here should be 4. Okay. If you want to calculate Px equal to 0. Okay, we want to calculate Px equal to 0 in if the mu is 4, meaning every 2 hours she will receive 4. So this is how you convert the interval or the mean value of Poisson proportionate to the event. Okay, which is what the which is what we discussed just now. The probability value is proportional to the length of the interval. So if there is 2 emails in 1 hour, so that mean it will be 4 emails in 2 hours. Okay, so that is how you convert. So here is also the same. Per minute means this is the interval. In 1 minute, there will be 3.1 vehicle theft, meaning 3.1 vehicles will be stolen in every minute. So all the questions will be in 1 minute, in 1 minute, in 1 minute. So it's just using this the same 3.1 as your lambda for question 51. Of course, this is not required in your assignment, but you can do this and you can check the answers at the back, okay, of the textbook. Okay, here, okay, okay, let me see question 52. Okay, no need to do 52 lah, 52 not questions. So let me see which one else. Okay, so 50, question 50, you need to do question 50. Okay, 52 cancel. Let's see. Okay, we do question 28 then. So for your simple 3 questions exercise, it will be question 26, 28, and question 50. Okay, question 50. Okay, 52 cancel. So we're not going to do question 50. Okay, so question 52 cancel. So 50, 28, and 26. Okay, so let's see how we do question number 25. Okay, So you can check chapter 6 solutions, okay, at the back of the book here. Okay, chapter 6. Okay, so chapter 6, questions number berapa tadi? 6. Okay, so this is 26, chapter 6. Okay, you can see here question 25. It will be 0. Okay, so let me just screenshot this screen here so that we can just refer to the answers. Oops, not a nice looking one. Okay, so 0. Okay, so it will be 0.6703. Okay, so let's go back to the questions just now. Okay, question 25, the answer will be 0.6703. Okay, so mu is 0.4. Okay, so the first one will be x equals to 0. Okay, so this one is 0.4, correct? And then here x equals to 0. So the first one will be x equals to, so you can see the answer is 0.67032, which is the same one here. B is 0.3297. Okay, so the question asks you to calculate px more than 0. Okay, so px more than 0 is what? Meaning 0 is not included, correct? Okay, x more than 0 means, or at least greater than, meaning more than 0. So 0 mean 1 and above. So the way that you can convert this will be to use, okay, so if you want to convert more than into a greater or more than, okay, greater or equals to sign. So it will be x greater or equals to 1, because above more than 0 means 0 is not included. So it will be 1 and above. So you need to plug in 1 in the calculator here, okay, instead of 0. So put 1. Okay, so you need to choose this one. Okay, because x greater or equals to 1. So you're going to get 0.32968. Do we get the same one? 0.32968, which is the same one, to 0.3297. Okay, as you can see, that's how you solve for the question. So if you want x greater than 0, so it will be at least greater than 1. So you put 1 here, choose the third option here. Okay, so that's how you solve for 25B. Okay, so I think the rest you can experiment on your own. Okay, so for the assignment, the short assignment, do question 26, question 28, and also question number 50. So I think these 3 exercises should be sufficient for you to at least get the basic understanding how to apply Poisson distribution. Okay, and any other questions, for example, like question 51, okay, you can check the answers at the back of the book, okay, because your second test, okay, will cover topic number 4, this one, binomial and Poisson, and also the next topic that we will learn next week, okay, inshallah. Okay, so that's it for today. Okay, so I will put up this video in your OL soon. Okay, so don't forget to submit the assignment by tomorrow noon, okay, the latest. So for Muslim, okay, Eid Mubarak, Eid Mubarak, Ramadan Mubarak. It is another 1 month from now. Okay, so happy fasting, and I'll see you in the next class. Okay, thank you. Assalamualaikum and good morning.